So this lecture is covering 1.2. We're talking about quantitative data, so we're going to be looking at the graphs such as dot plots, dot plots, stem and leaf plots. We'll be looking at histograms. Here, once again, are your learning objectives. You'll find them in the textbook at the beginning of each section. You'll find the accumulation of all of the ones from the sections in a chapter at the end, as well as on the checklist that I've given you in your notebook. So we're going to be talking about describing the distributions in dot plots, step plots, and leaf plots. Once again, distribution, once again, is talking about how often and what kinds of values are shown in a particular thing. The shape of a distribution, we're going to talk about that, and then we're going to compare distributions, particularly looking at comparisons of histograms as well as box plots. Box plots will be in the next section. I don't need to talk about this, you guys can read, but basically the key issue is you want to look at your maximum and your minimum, figure out where you need to start your graph and where you need to end your graph, and then mark accurately and consistently, numbering consistently as well. When we're looking at a distribution, and remember distribution just means how often certain values occur, you're going to pay attention to the shape, the center, and the spread of the distribution. Shape is something you can talk about easily, just looking at one graph. Center, you're going to talk about easily looking at one graph. Spread, you probably won't notice much to talk about in terms of the spread unless you're comparing two things. We have this mnemonic device called SOX. It reminds you to do shape, talk about how the outliers affect stuff. That's what the O stands for. What's the center and what's the spread? So some of you mentioned yesterday the bell curve. Symmetrical does not have to be perfectly symmetrical. This is an example of trials of dice rolls of two dice and their sums. If it were looking at the theoretical probability, it would be perfectly symmetrical. But we know that there's definitely some luck involved with just that many dice rolls. But it's close to symmetrical. Symmetrical left and right sides are approximately mirror images. In this particular case, this low set of scores skews the information to the left. So when you talk about skewing, you want to think about the data value that's pulling it. That's the direction that you're going to talk about. This one is skewed to the right because there was one family with a lot of siblings. So shape, symmetrical, skewed left, skewed right. When we compare distributions, we want to pay attention to the shape. In this case, both graphs are fairly, this first one is not symmetrical. This first one is skewed to the right. Because this one household with the 27 household members pulls the data over to the right. This one is fairly symmetrical. Both of them are what is called unimodal, which means they have one concentration of data. The center of this one, we're going to talk more about center when we talk about mean and median in the next section, but you can look for about the center of the data somewhere in there. You can eyeball it or you can start calculating it using the median, but we'll talk more about that or later. Making a stem and leaf plot, once again, you can go ahead and read this to yourself. What's key issue though with a stem and leaf plot is you're going to want to start with the smallest to the largest. Okay. In a vertical column, you're going to draw that line. And then each leaf is to the right of the stem. So if we were talking about test scores, for example, and we had a 72 and a 73, and then an 81, and then a 92 and a 92, you're going to go ahead and make sure that your I apologize, my throat's doing something funky. that your numbers here, and I'm going to move to a highlighter so you can see that, your numbers here are going in ascending order, and they are in order. And then these are in ascending order, and they are in order. And of course, you're going to lose points unless you include your key. In this case, my example had to do with test scores. So we'd say a 72, a 7-2 means a 72% on the test. You're going to make sure you include a key whenever you make any stem and leaf plot or any item that has more than one thing. So you need to So this is an opportunity for you to practice stem and leaf plots. We're not going to practice any more in class. We've already practiced one. There are several homework problems that ask you to do so, but interpreting them is definitely something that you want to practice, and we'll do that a little more. Back-to-back stem and leaf plots, by the way, we did one in class. The one in class didn't have this feature, which is called split stems. And that you'll notice right here. You'll notice right here that they have split the zeros, so they would do 0, 0, 0, 1, 0, 2, 0, 3 in this one, and then they would do 5, 6, 7, 8, 9, and then 10, 11, 12, 13, 14, and then 15, 16, 17, 18, 19 there. So it allows you to see the data a little more carefully. Otherwise, the points are too long. And you only need to split the stems when the distribution is big or when the data values are bunched up. Just to clarify, you need to be able to make a dot plot. You need to be able to make a stem and leaf plot. You need to be able to make a histogram, but you definitely need to interpret more. So if you know you can make them, don't stop there and think that you're done. You need to be able to read them, communicate about them, and compare them. So histograms are the last of the graphical representations that we're going to use in this section. And when we deal with a histogram, histograms are good when there are data items that are separated by like decimal points like GPA, or something where they're close to one another. It's just a little more useful to talk about them in terms of their classes. I used the term bin in class the other day, and that really just means what fits in each bar. So you're going to go ahead and start like we always start. Find your minimum and your maximum. So you decide how long your y-axis, your x-axis has to be, my bad. And then you're going to decide, you're going to split it into data ranges of equal width. And once again, 5 to 7 is 8 is fine, 4 is fine, but 5 to 7 is pretty much what you're looking for because that'll give you the most information. And then you're going to go ahead and make tallies in each of those classes, and then make that bar in that class as high as the number is. Once again, remember frequency on your y-axis is the total number of times it happens, and relative frequency is the percent of time it happens. And what relative frequency is super helpful in two situations: when the data set's really big and it's hard to really understand by raw number, or also when you're comparing two things that have a different data point, a data amount, and that'll allow you to understand and compare them a little better. Unlike a bar graph where the bars don't always have to touch, histograms bars do touch, unless of course you have like in our class there were never mind. So here you can go ahead and figure out what you would do with this, but they've already figured out what the classes are. They decided from 0 to 5, but it's not 0 to 5, it's 0 then less than 5. So what would go into this count are the percent of foreign born that's 0, 0, 1, 2, 3, and 4 right here. Once something is 5, then 5, 6, 7, 8, and 9 would go in this group, etc., etc., etc. So it's always, if this 5 is your marking point, the stuff before it is 0 to 4, 10 is your marking point, 5 to 9, etc., etc. It's always this marking is the stuff before it. Okay? Some common mistakes that students make. They don't, you know, I'm going to add the part that you got to make sure you put your title. You got to make sure you label your axes and make sure it's really clear what's going on. Be really careful. Don't confuse a histogram, which will have numerical data, with a bar graph. A bar graph is going to have a category on your x-axis, and a histogram will have numbers on your x-axis. But remember, we can take numbers like a range of ages and make that into a category. So pay really careful attention. Second place where people make mistakes, that histogram, remember, has got to start on the y-axis at 0 and count whatever makes sense in terms of the frequency. Otherwise, it's misleading. Pay attention to that. Look out for that. You do not want to let yourself be misled. Percents when there's different counts. And I don't really know what they're trying to say here, but just because your graph looks nice doesn't mean it's a meaningful display of data. I'm not sure what that is about. So this is what you need to make sure you're able to do. Can you make a dot plot accurately? Can you make a stem plot accurately, including the idea of a double stem? Or one where you have to split the stems, okay? We're going to talk a lot more about describing the overall pattern of the distribution. That's a very, very important thing, so we'll spend a lot of time on that in class. It's identifying the shape is going to be our focus here, and then we'll continue to talk more about center and outliers on Friday, and then we'll do some work with spread on when we get back on Tuesday.